Hello everyone, welcome to In 5 Minutes. In this video we will solve one sum based on bilinear transformation. The question is, the analog filter has transfer function that is h of s is equal to 1 upon s plus 1. We have to use bilinear transformation technique and obtain the transfer function of digital filter or h of z and also write the difference equation of the digital filter. So let us solve this. The given transfer function is h of s is equal to 1 upon s plus 1. Now using bilinear transformation, h of z will be obtained by this formula, that is s is equal to 2 by ts z minus 1 upon z plus 1. Now we can see that ts is the sampling time, but it is not mentioned here. So we will assume that ts is equal to 1 second. So substituting ts, we get 2 into z minus 1 upon z plus 1. Now we have to put this value in this equation, that is h of s. So while substituting this equation, we get h of z is equal to 1 upon 1 plus 2 into z minus 1 upon z plus 1. We will simplify these terms. We get 1 upon z plus 1 plus 2 into z minus 1 the whole divided by z plus 1. This z plus 1 will go up. So we will get z plus 1 upon z plus 1 plus 2z minus 2. So it is z plus 1 upon 3z minus 1. This is the transfer function of digital filter. So we can express this as h of z is equal to y of z upon x of z, that is z plus 1 upon 3z minus 1. So now we have to convert this into negative power of the z. While converting to the negative power of the z, we have to divide the numerator and denominator by z. So y of z upon x of z is equal to 1 plus z raised to minus 1 upon 3 minus z raised to minus 1. This is done by dividing z on both the sides. Now we have to cross multiply to get the inverse z transform. So first we will bring this equation by cross multiplying. So by cross multiplying we get y of z into 3 of z raised to minus 1 is equal to x of z into 1 plus z raised to minus 1. So we will expand these terms, that is 3 into y of z minus z raised to minus 1 y of z is equal to x of z plus z raised to minus 1 x of z. So it is like the form of normal linear equation. So we will take inverse z transform on both the sides. Inverse z transform will result into 3 into y of n minus, as it is z raised to minus 1 term, this inverse will be y of n minus 1. Similarly, here it will be x of n plus x of n minus 1 due to this minus 1 term. Now we will take all the minus 1 terms, like we have to form these equations in the form of y of n to find out the difference equation. So it will be like 3 into y of n is equal to x of n plus x of n minus 1 plus y of n minus 1. So we will divide this 3 on RHS. So finally we will get as y of n is equal to 1 by 3 x of n plus x of n minus 1 plus y of n minus 1. This is the required difference equation of digital filter, and thus we have found out the bilinear transformation. Thank you.